Topic: Ohm's law. Teacher. Revise 1. Component symbols. Cells in series and parallel. Lamps in series and parallel. Switches in series and logic and parallel or logic. Current in the circuit, conventional. Current flows from positive to negative. Revise 2. Simple circuits. 1 cell, switch, 2 lamps in series. 2 cells in series, switch, 2 lamps. In series. Ohm's law. Explanation. Explanation of instructions and mediating concepts of component symbols. Explanation of instructions and mediating concepts of simple circuits and Ohm's law. Pictures / illustrations of component symbols, simple circuits and Ohm's law quantitatively. Also practical demonstrations of simple circuits and Ohm's law quantitatively. Video clips of simple circuits. Pictures / illustrations / video clips. Content and explanation. General. Light-dependent resistor. Symbol. Converts brightness, light, to resistance. Input component. Resistor. Restricts the flow of current, for example, to limit the current passing through an LED, process component. Light-emitting diode. Converts electrical energy to light. Output component. Push switch. Allows current to flow only when the button is pressed. Output component. Microchip. To keep track of activities and information process component. Solenoid. A coil of wire which creates a magnetic field when current passes through it. Converting electrical energy to mechanical energy by pulling on something. Output component. Thermistor. Converts temperature, heat, to resistance. Input component. Variable. Resistor / potentiometer. Used to control voltage. Process component. Loudspeaker. Converts electrical energy to sound. Output component. Microphone. Converts electrical energy to sound. Input component. Transistor NPN. Amplifies current. Current flows from collector to emitters. Process component. Transistor PNP. Amplifies current. Current flows from emitter to collectors. Process component. Motor. Converts electrical energy to kinetic energy. Motion. Output component. Battery. Supplies electrical energy. A battery is more than one cell. Capacitor. Stores electric charge. Process component. Buzzer. Converts electrical energy to sound. Output component. Magnetic switch, used to detect the opening of doors and windows. Input component. Diode, allows current to flow in one direction. Process component. Bulb / lamp, converts electrical energy to light. Output component. Revision 1. Component symbols. Components are the parts that we connect in an electric circuit. The simplest circuit has a power source such as a cell, a conductor, and a load that provides resistance such as a lamp. Cells in series, switches in series. Switches in parallel, cells in series. Cells in series. 2 or more cells can be connected in series to increase the voltage in the circuit. Figure 2 below shows 2 cells connected in series in a circuit. The positive terminal of cell A is connected to the lamp. The negative terminal of cell A is connected to the positive terminal of cell B, and the negative terminal of cell B is connected to the other terminal of the lamp. In series means the cells are connected end to end, and the current flows through each cell in turn. Figure 2. Cells in parallel. 2 or more cells can also be connected in parallel. A parallel circuit has 2 or more different paths for the current to travel along. Figure 4 below shows two cells connected in parallel in a circuit. The positive terminals of both cells are connected to each other and to the lamp. The negative terminals of both cells are connected to each other and to the other terminal of the lamp. Lamps in series, lamps in series. Two or more lamps can also be connected in series. Lamps in parallel. The applied voltage is the same across each lamp. We can use two or more switches to control components in a circuit in more complex ways. In a logic circuit, an open switch is regarded as having a value of 0, and a closed switch as having a value of 1. If the circuit is not completed, the output is in the OFF state and has a value of 0. If the circuit is completed, the output is in the ON state and has a value of 1. Lamps in parallel. Two or more lamps can also be connected to the cell in parallel, as shown in the pictures below. The positive terminal of the cell is directly connected to the A side of the lamps and the negative terminal to the B side of the lamps. Switches in series and parallel. In a circuit with one switch, the switch controls whether the current flows through the circuit or not. If the switch is open, no current flows as the circuit is not completed. The closed switch allows the current to flow. Switches in series. In the circuit on the right, there are two switches in series. This gives us 4 different switch combinations. They are switch A and B both open, switch A open and B closed, switch A closed and B open, and both switches closed. Do you see that the current cannot flow through the circuit if either switch A or switch B is open? Both of them must be closed for the lamp to glow. Switches in parallel. In the circuit on the right side, there are two switches in parallel. This also gives us 4 different switch combinations. Figure 12, circuit with two switches in parallel. The current can go through the closed switch even if the other switch is open. Refresh Ohm's law. There is a special relationship between the voltage, current, and resistance in any circuit. You can control any one of these 3 variables by changing the other 2 variables. Ohm's law states that as voltage increases, the current increases if the resistance is constant. In the formula for Ohm's law, V is the potential or voltage difference measured in volts. I is current measured in amps and R is resistance measured in ohms. Links of videos to assist. Worksheet. Use prior knowledge and complete the following questions. 1. Draw a circuit diagram of the circuits in the space provided on right. Figure 2. Two cells in series connected to a lamp. 2. Figure 3 below shows 3 cells connected in series in a circuit. Draw. Figure 3. 3 cells in series connected to a lamp. 3. Draw a circuit diagram of the circuit in Figure 4 in the space to the right of it. Figure 4. 3 cells in parallel connected to a lamp. In the table above on the right, 0 means off or open, and 1 means on or closed. Complete the table to show all the different combinations possible in the circuit above. 5. In the circuit below, there are 2 switches in parallel. This also gives us 4 different switch combinations. Complete the truth table below for the circuit.